Hello again and welcome to my science channel. Today we're going to have a look at power supplies. So what is a power supply? What does it do? Well, essentially it takes AC in from our mains and transfers it to a lower voltage DC. So we know that our mains voltage is sinusoidal coming in, so it's a sinusoidal wave. But what does a battery voltage look like? Now, if we had a battery and put that in the oscilloscope, now if it was the mains voltage, and we'll come to this later on, if it was the mains voltage, we'd see a sinusoidal wave there. But if we did it to a battery, if we had a look what a battery output looks like, now this is set to 5 volts per square on that. So each division is 5 volts. This is a 9-volt battery. So I'm estimating it's going to come up just short of that square there. So let's have a look. And there we are. So that's 9 volts and it's DC. It's a straight line, a flat line. And that's what we're looking for from our power supply. So we want AC in and we want a flat line DC out. So how does it do that? Well, if we have a look inside, and this is a safety thing, the plug is out, and if you don't know what you're doing, then you can't look in here, because if you did touch the wrong thing and it was connected to the mains, then it could actually kill you with an electric shock. So it says do not remove screws. So I've removed all the screws, and now we're going to have a look inside. So what we can see is a number of components in here, and you can see a transformer, you can see a capacitor there. And if we take this little board out, we can see on the board some diodes, and they're connected in a particular way. So what we're going to have a look at now are these components in their own right, and then we're going to put them all together and look at them on the oscilloscope, and then we're going to make a block diagram to show a regulated power supply. Okay, so let's have a look at each of these components in the power supply individually. First of all, we have the transformer in there, which is being our step down from the mains voltage. So if we have a look at it, we've got 2 windings on our transformer. Primary, where our mains goes into at 230 volts, and our secondary, which will have less turns on it. So the voltage will actually come down, the amplitude of the voltage, or the height of the wave, if you like, will come down. So we can see a 230 volt sinusoidal wave going into the transformer there, and coming out the other side of the transformer, secondary, still a sinusoidal waveform. So the waveform's unchanged, but it's lower in amplitude, so the voltage is being decreased. So the second component that we have in there is a diode. Now if you notice though, there's 4 diodes in there. But if you notice this one diode, which looks like that, so if you have one diode in there, you get something called half-wave rectifications. So you have a sinusoidal wave going into the diode, and coming out of the diode, that's half-wave rectified. So what that means is it's chopped off the bottom half of the wave. The negative half of the wave has been cut off. So you have a gap. So you have a wave, a gap, and a wave. So that's a diode giving you half-wave rectification. But we don't want half-wave rectification in the power supply unit. We need a full-wave rectification. And to get a full-wave rectification, we need something called a bridge rectifier. And that's why you can see 4 diodes in the power supply. They're 4 diodes connected in the form of a bridge, and we put an AC signal into it, and then coming out of it we got that half wave that we lost in the half-wave rectification. The half wave has now been put onto the positive part of the cycle, so we've got a full wave rectifier. So this is now a kind of a rough DC, it's a pulse DC coming out of there. So we get in somewhere now towards where we want to be with a battery voltage. Next, we put a capacitor in. Oh, what I forgot to mention, if you didn't want to use 4 diodes for a full wave bridge, you can actually buy a bridge package and that contains the 4 diodes in that package. So capacitor, which looks like this. We've seen capacitors in my other videos, and this is one of the uses for them. Now it's a smoothing capacitor. So what we do is we put the full wave rectified supply across the capacitor, and what the effect of that is, it smooths it, so you will have just a small ripple voltage. So it's getting towards a line there, but as you can see there is some ripple in it. Now that depends on the size of the capacitor as well, because with a big enough capacitor you can take most of our ripple out. Now that comes to the final section. It's not one on here, so the actual output of this with a little tiny bit of ripple on it is okay for the unit it was supplying. If we want a specific voltage, an absolute solid line voltage like we saw off the battery, we use one of these, and that's called a Zener Diode. And the symbol for a Zener Diode is like a normal diode, but with a little line going off the cathode side. That's the anode side, that's the cathode side, and with a little line going back. And here's the ripple voltage coming off the smoothing capacitor. But after the Zener Diode, this is called regulation. And after the regulation, we get the solid line out that we wanted with the battery. So that is what the components within the power supply do. So next, what we're going to have a look at is those components when we connect them across the oscilloscope. So we've connected up now our power supply. I've taken the transformer from the other power supply. So we've got a transformer, we've got a bridge rectifier made of 4 diodes there, and we've got a smoothing capacitor. Now I've put a switch in the smoothing capacitor so we can switch it in and out of the circuit to see what it actually does. So first of all, we're going to pick up the supply from here and have a look at it on the oscilloscope. As you can see now, we've got the output of the transformer, which is sinusoidal. You can see that, so that's an exact reflection of what's happening on the mains, only the voltage is severely decreased. So that voltage is about 17 volts there, whereas the mains is coming in at about 230. So we can see that we've got a lower voltage sinusoidal waveform there, and what we're looking for is that flat line. So we'll have a look now on the other side of the bridge rectifier to see what our signal looks like at that point. So what you can see now here is the full wave rectification. The negative half cycle has been cut out and put up on the positive half cycle, and you can see the peaks of the waves here with a little bit of ripple voltage on there as well. There's a bit of noise in the circuit coming from somewhere as well, but as far as we can see there, we've got the full wave rectification. Now if I switch in the capacitor, look at that, see the difference that makes? That's actually causing it to smooth. Now it's smoothing, and there's pretty much a straight line there. There'll be a tiny bit of ripple on that straight line. If we switch out the capacitor, we can see the effect that that has again. So during the discharging part of the cycle, the capacitor is feeding into the circuit to give pretty much a straight line there. Okay, so if we wanted to remove that ripple totally, we can put regulation into it. So we can either put in a Zener diode like that, or you can have the 3-pin package which will do your voltage regulation for you. So if you wanted a fixed voltage out, you can put one of these regulators in, and then you would have a constant voltage at your output of your supply. So the regulation components of the Zener diode and that power. To look at a circuit diagram then of our power supply, we've got a transformer coming in, taking our high voltage to a low voltage. We've got the bridge rectifier, so it's doing the rectification stage. We have a capacitor across there, which is doing the smoothing stage. And then the regulation for the fixed voltage output, the regulation by here being done by a Zener diode. Or if we take that section out, we can put our 3-pin device in there, which you can see the 3-pin connections of our encapsulated voltage regulator there. And that's it for power supplies. So you can see a regulated power supply there. So I hope you enjoyed that and I hope you've learned something from it. Looking at the components that we have, and we've seen what each component does, we can put a block diagram together of the power supply. So use our transformer with our AC going into it and our reduced amplitude coming out of it. Then we've got a bridge rectifier, which are the 4 diodes connected together in the bridge form. So after that comes out a full wave rectification, like that. Then we have the smoothing capacitor in there. And after the smoothing capacitor, we've got this little bit of ripple there. Then we've got the regulation, which is the final block, the Zener Diode. Or you can actually buy a package, a little 3-pin encapsulated package, which will give you a regulator, and you can select what voltage you want, 5 volts, 10 volts, 15 volts or whatever. And after the regulation stage, we've now achieved our flatline DC. So using these 1, 2, 3, 4 stages, we've gone from a 230 volt sinusoidal supply right through to a lower voltage of our choosing by these components of a flatline DC at say 5 volts, 10 volts or whatever we want. And that's what our power supply does. Thank you very much.